Hello, everybody. So here is just some quick pre-algebra and algebra 1 review topics before we go into our next trig unit. So please pause the video and factor these four expressions. The first one is a difference of squares. It's a square minus a square, so it factors into x plus 1 times x plus 1. Here you have to find two numbers that multiply to 1 and add to -2. It happens to be -1 and -1. But these two binomials are the same, and since you're multiplying them, it's really just x minus 1 squared. So that means this trinomial is a perfect square trinomial because it was just one thing squared. Same thing with this. This is 2x minus 1 squared. What do I do here? The GCF is always the first thing you look for. These first three had a GCF of just 1, so pulling out a 1 didn't help anything. But here, both terms have an x squared in common. So you factor that out and you're left with this. And now you also have to know that you cannot continue. There's nothing else to factor. It's close to a difference of squares. You've got the difference part. This is a square, but this first term is not a square. That x ruined it for us. Pause the video and factor there's first four from 5 to 8. So please pause the video and factor these four. Number 5 is also a difference of squares. It's going to really help you to identify when you've got a difference of squares. Same thing with number 7. Number 6, there are two numbers that multiply to 1 and add to 2. It's x plus 1 and x plus 1. So that is x plus 1 squared. And number 8, again, GCF of x. So you could factor that x. How do you do 9 and 10? You still have to factor. Well, this is new notation, sine squared. What does sine squared of x mean? It means sine of x times sine of x. So sine squared of x is sine of x times sine of x. Don't say or think sine times sine. You have to think about the domain and say the domain every time. Sine of x times sine of x plus sine of x. Well, can I even factor this? Yeah, just like number 8, they both had an x in common. Number 9, they both have a sine of x in common, so you can factor that out. And it becomes sine of x times sine of x plus 1. Number 10, again, a difference of squares. So that factors into cosine x minus 1 times cosine of x plus 1. This chapter is about proving trig identities, which we will study tomorrow, and solving. And one of the most common ways to solve is to solve by factoring. So to solve by factoring, you have to, so let's say we're gonna solve this. So here's an equal sign, which means I've got an equation, and I wanna find what x values make this equation true. So I wanna solve by factoring. So that means I've gotta set it equal to 0 first, minus 1, and then factor. So it's a difference of squares. Now what do? I set each factor to 0 and solve. So one factor set to 0, the other factor set to 0. I can add 1 to both sides. Here I subtract 1 to both sides. And now I have to think about my unit circle. What angle has a cosine of 1? What angle has a cosine of -1? And the angles that have a cosine of 1 begin at 0. And then if you go around a full circle, you're at 2 pi. Another full circle, 4 pi, 6 pi, and on and on and on. For -1, pi has a cosine of -1. And if you go around a full circle, you've got 3 pi, which also has a cosine of -1. So this is an example of how we would solve. This is a problem that could easily be on a quiz or test. Pause the video, please, and solve these two by factoring. Well, it has to be set to 0. Number 11 is. So I set each factor to 0, and I discover that x equals 0 and x equals 5. Degree 2, so I'm looking for 2 answers. Number 12, you must set it to 0 first. So the first thing you're doing is subtracting 5. Then you're going to factor, set each factor to 0, and solve. So +5 and -1. How do I divide fractions? You flip and multiply. So the divisor is 4/5. We're going to change division to multiplication. And we're going to change the divisor 4/5 into 5/4. and it becomes 15/4. Same story here. You're dividing by 4/5, so that's the same thing as multiplying by 5/4. The 5 up here and the 5 and the 10 cancel out, and that's how we get 3/8. Sometimes when we are proving trig identities, we want something that is in one fraction to become two fractions. Sometimes we have two fractions that we want to become one fraction. Well, with this one, I can split it up into two different fractions because the x squared and the 2 are both being divided by x. So x squared divided by x and 2 divided by x. So I can split this one fraction up into two fractions. Here, not so much, because I can't just say x is being divided by x squared. That's not true. X is being divided by x squared plus 2. So here there's no real easy method of splitting up this fraction. So we're just not going to, we're not going to do that in this class. So the short answer is when you cannot split up the denominator, but you can split up the numerator. See, the numerator got split up into one fraction for x squared and the other fraction for 2. What if you have two fractions? How are you going to make them into one? By getting a common denominator and subtracting. So you can always get a common denominator, always. Now look here for about the 9th time. What do I have? I've got x minus 1 times x plus 1. Wouldn't that have been the result of a difference of squares? X minus 1 times x plus 1? Yes. So realize that, and you can skip all the double distributing and just get x squared minus 1. The numerators change too. 2 times x minus 1 becomes this. 3 times x plus 1 becomes this. So I want you to predict what is underneath this green box. This fraction minus this fraction. The denominator is going to be x squared minus 1. No surprise there. But what is the numerator? 2x minus 3x is negative 1x. Negative 2 minus 3 is negative 5. So this is the one fraction. So again, the big picture is, in these last two examples, in number 15, you could take one fraction and split it up into two fractions. You can do that when you split the numerator. You cannot split the denominator. In problem 17, you had two fractions that you converged into one fraction. This is just by getting a common denominator and adding them up. 18, how can I get rid of this irrational number that's in the denominator? You need something called the conjugate, which is an important math term, the conjugate, which is a binomial that has the opposite sign. So this is a binomial that has plus, its conjugate is a binomial that has minus. And realize, what does this red value equal? 2 minus rad 7 divided by 2 minus rad 7. What does that equal? That equals 1. So I'm taking this ugly black number times 1. And that doesn't change the value. And sorry for hurting this number's feelings. This is a very beautiful number. And let's continue. Again, look at this denominator. Do you see that you've got a difference of squares in the air? You've got a binomial times a, look at the bottom, a binomial times a binomial. One is plus and one is minus. Just like this, binomial times a binomial. One is plus, one is minus. Just like, I don't have to go too far to find one. Here, binomial times a binomial. One's plus, one's minus. Binomial times a binomial. One's plus, one's minus. These are all difference of squares. Differences of squares. So when you multiply the denominator, realize that you've got basically a difference of squares. So what's going to be in the denominator? The first term squared, so 4, minus the second term squared, which is 7. So 4 minus 7. The numerator, well, that's 3 times 2, 3 times rad 7. And 4 minus 7 is negative 3. All three of these terms have a negative 3 in common. So if you take a negative 3 away from 6, you're left with negative 2. If you take a negative 3 away from the negative 3 rad 7, you're left with positive rad 7. And negative 3 divided by negative 3 is positive 1.